Hi there. Here we are with another little tricky one. AQA June 2018 paper 2, question 8, and this is worth a fairly hefty 7 marks. So what we're asked to do is determine the series of transformations that map sine x, y equals sine x, onto y equals this composite function of root 3 sine x minus 3 cos x plus 4. I hope when you see that you'd be thinking, I'm going to represent that in the what's called the harmonic form, or rather the r brackets or r sine x minus alpha. Okay, this is obviously using the compound angle expansion. So we're going to expand this out generically. We end up with r sine x cos alpha minus, because it's the sine value or the sine function, it's the sine stays the same here, and that becomes r sine alpha cos x. Okay, so we can compare this with this, just this bit in here, not the plus 4. Okay, so I know that I'm going to deal with this first. So r cos alpha, and then multiplied by sine x minus r sine alpha multiplied by cos x must be equivalent to root 3 sine x minus 3 cos x. Okay, so you can sort of clearly see from this that our r cos alpha must equal root 3, and above I'm going to write r sine alpha is equal to 3 here. The negatives are obviously the same. I've written them that way round because I have two equations, 1 and 2, and if I divide 1 by 2, okay, I'm going to basically divide the top one by the bottom one. I end up with sine alpha over cos alpha, so I get tan alpha equal to 3 upon root 3, which is the same as actually root 3 upon 1, or just root 3 if I rationalise. So immediately, if you find the inverse tan of that, you should be able to find alpha quite straightforward, even without a calculator. Inverse tan of root 3 is 60 degrees, or pi by 3 in radians. Okay, so we found out what alpha is. We can also use the relationship that r squared is equal to the coefficients of sine x and cos x squared, and so we get root 3 squared plus 3 squared. So r squared is equal to, a little more like an r, 3 plus 9 is equal to 12. So r is equal to root 12, which is equal to 2 root 3. Okay, so we can plug that into our function up here and make it so we know that y is equal to, in this case, this I'm going to replace with r sine alpha, which is going to be equal to 2 root 3 sine, x minus alpha minus pi upon 3, and then add 4 at the end. Okay, so we can actually see now that we've got a much more digestible equation to deal with our transformations. Okay, so here we have a transformation in x. Remember, we're setting the thing in brackets to 0, so x would be pi by 3. So we've got a pi by 3 positive and 0 in y. Here we have a transformation of 0 in x and moved up 4 in y. And here we have a stretch in y, scale factor 2 root 3. Okay, so the order in which they're done, our x transformation is done first, followed by our it's got to be the stretch next, because then it will scale that up, and then finally our transformation of 0, 4 and y. Okay, so quite a chunky question, quite a lot of scope to go wrong, but there's our 7 marks. Okay, thanks.